Continuing on with our discussion on multiplicity, let x equal alpha be a zero of multiplicity m of the polynomial p of x, where m is greater than or equal to 1. Then p of x can be written in divisor quotient form, as in p of x equals x minus alpha to the power of m multiplied by q of x, where q of alpha does not equal 0. Now if we apply the product rule of differentiation, we have p dash of x equals m outside of x minus alpha to the power of m minus 1 multiplied by q of x plus x minus alpha all to the power of m multiplied by q dash of x. So that's our u dash v plus u v dash. That's our u, that's our v. Now if we factorize out x minus alpha to the power of m minus 1, we have p dash of x, our first derivative, is equal to x minus alpha to the power of m minus 1 outside of this expression here. Hence, x equals alpha is a zero of multiplicity m minus 1 of the polynomial p dash of x. After all, if we start off with a polynomial and then differentiate it, we end up with another polynomial, except that the second polynomial is a derivative of the first polynomial. If m minus 1 is greater than 0, then p dash of x may be differentiated again until the multiplicity reaches 0, at which point the multiplicity of the 0 may be determined by the number of times p of x was differentiated. So every time we differentiate p of x, and then find the second derivative and possibly a third or fourth derivative, the multiplicity drops by 1. And when it reaches 0, we've kind of hit a sort of an end point, at which point then we can count the number of times we differentiated, and from that we can then determine the multiplicity of that 0.